Yeah. Okay. Uh, but suppose whenever we are watching movies or whenever we are doing some work, okay, we are not doing only single work. We are doing like multiple tasks. But suppose whenever we are watching movie, we are eating something. Okay, we are charting something. Okay. Now we are speaking something. Now the person is the only one that doing multiple tasks. Okay. The person is the only one doing multiple tasks. Okay. Now the process is called multitasking. Okay. Multitasking. Okay. What does it mean by multitasking? Executing several tasks simultaneously. This process is called multitasking. Okay. Executing several tasks simultaneously. This process is called multitasking. Okay. Now, again, the multitasking is divided into two types. Okay. The first one, process based multitasking, and thread based multitasking. Okay. Process based multitasking and thread based multitasking. Now, what does it mean by the process based and what does it mean by thread based? Okay, basically multitasking in the sense like executing several tasks simultaneously. Now, this process is called multitasking. Okay, again, this multitasking is divided into two types: process based multitasking, okay, and thread based multitasking. Okay, process based multitasking and thread based multitasking. Now, what does it mean by process based? Okay, here also executing several tasks simultaneously. Okay, executing several tasks simultaneously, where each task separate independent process. Okay, now where each process, okay, separate independent process. Okay, now it is called a process based multitasking. Okay, now this type of multitasking is called process based multitasking. Observe here. Executing several tasks simultaneously. Now, where each process, okay, where each process separate independent process. Okay, now each task separate independent process. Simply, this type of process we can call process based multitasking. Okay, now where we can use this process based multitasking, we can use in the OS level. Okay, in the OS level, we are going to use the process based multitask. Simple example, for suppose, okay, now downloading one file from Google. Okay, now typing some code in Eclipse. Okay, at the same time, uh, listening some music in the VLC media player. Okay, these things we can do at a time. Okay, one file is downloading from the Google. Okay, at the same time I'm downloading I'm writing some code in the Eclipse, and at the same time I'm using the music from the VLC media player. Okay, here we have the three processes. Simply here three applications. Now here we have the Google and the Eclipse and again VLC media player. Okay, these are the three processes simply. Okay, applications. With these three applications, simply we can say it's a process. Okay, each application we can call it a process. Now These three applications running on simultaneously, where each task is a separate independent process. Okay, these applications are depends on like a OS level only. Okay, now these all the applications are running on the OS only. Okay, now this all these tasks are okay doing simultaneously. Okay, simultaneously here, executing several tasks. Now downloading file, listening the music, typing the code simultaneously, where each task, okay, where each task separate independent process. Okay, this process called process based multitasking. Now, what about like thread based multitasking? Okay, what about like a thread based multitasking? Observe here, executing several tasks simultaneously. Now, where each task, okay, where each task is separate, independent of, okay, separate independent of same program. Okay, now it is a process based is a separate process, independent process. But here, executing several tasks simultaneously, where each task is separate independent of a same program. Okay, only one program. Okay, within the one program, separate independent tasks. Okay, separate independent tasks. Now it is best useful for programmatic level. Okay, it is best suitable for programmatic level. Now, for suppose simply here, when client came to like developer, now he asked to execute 1,000 lines of code. Okay, the developer said it will take a 4 hours time. Okay, now again the client needs emergency to execute the code, but again he asked the same thing: 1,000 lines of code need to execute. I need within 2 hours. The developer said like, okay, I can execute. Now you need to give more money. Okay. Now first he said like 4 hours, but again he said like 2 hours. How it is possible? Okay. Now with money simply we cannot execute speed, right? Okay. The same and 1,000 lines of code only. Now the developer applied a threading concept. Okay, threading concept. Now here he divided the code of 500 lines of code and 500 lines of code. Okay, he divided the code 500 and 500. Now, now he divided the code 500 500. Now, observe carefully here. Executing several tasks simultaneously. Now, where each task separate independent of same program. Okay, now these 1,000 lines he divided same program, separate independent task. Now he created these 500 lines is executing one thread, and these 500 lines is executing one thread. Okay, these 1,000 lines are executing, sorry, these 500 lines are executing one thread, and these 500 lines are executing one thread. Two threads are executing. Basically, here in this case only one thread is executing, but in this case that multiple threads are executing simultaneously, where each task is separate independent of the same program is divided the task executing simultaneously. Okay, now that's why it's a best suitable for programmatic level. Okay, programmatic level. Now here, now which one we need to take here? Okay, which one we are going to use here in the process based multitasking or thread based multitasking? Okay, now if you want to create like any kind of application, okay, the big kind of application, now you can go with like process based multitasking. Why? In the sense, the process based multitasking is a heavyweight. Okay, the process is a heavyweight. The combination of all the multiple process based is a heavyweight. Now thread is a lightweight process. Okay. For suppose in the physics we have the word called atom we have. Okay. Atom we have. Atom in the sense within the atom what we have? Electron, proton, neutron. Okay. Electron, proton, neutron. Okay. Now compared to like electron weight, atom weight is a more. Why? Within the atom we have electron, proton, neutron we have. But electron weight is less. Okay, here electron is a one thread, proton is a one thread, neutron is a one thread. The combination of the threads we can call it a process. Okay, the combination of all the programs we can call it an application. Okay, now that application is a process. Okay, within that application, executing multiple threads. Okay, now that's why the thread is a lightweight process. Okay, the thread is lightweight process. That's a point. Now, here, then what is the purpose of the thread-based multitasking? The thread-based multitasking mainly suitable for the programmatic level. Okay, the programmatic level. That's why we are going to use the concept is called multi-threading. Okay, multi-threading. Now, multiple threads are executing simultaneously. Now, where each task is separate, independent of the same program. Okay. Now, what is the main objective of the multi-threading here? What is the purpose? What is the main objective of multi-threading concept? Okay. Now, why we are using? Okay, that is the point here. Now, here by using multi-threading concept, we'll get the response time is a less. Okay, whenever we are interacting with any application, if it is internally using like any multi-threading concept, the response time is less. Okay, now whenever the response time is less, it will improve the performance. Okay, it will improve the performance. Okay, in our system also right now currently multiple threads are executing internally. Okay, observe carefully here. Now, if you consider Notepad plus plus is one application, one process. Okay, one process. Now, here Notepad plus plus is one application, right? One process. Within the process, observe carefully here. Okay, I am writing some code, typing some code. Typing some code is executed by one thread. Giving suggestions, all these suggestions are executing one thread. Okay, multiple threads are executing simultaneously. Okay, now writing some code is executing one thread. Okay, giving suggestions, executing one thread. Okay, the two threads are executing right now here. Okay, if you consider right now in my application, I open only the Google. Okay, inside the Google, we are using like some WhatsApp, something other application, and again Notepad plus plus and Eclipse I open. Okay, observe carefully here. Here I open only three applications, but in the background, how many applications are running? Observe carefully here. Now, see, 261 process are running internally. Okay, this 261 processor doing okay 3000 like 20 threads are doing okay 1,22,000 tasks. Okay, means what? These threads are handling like this many tasks. For every micro milliseconds, the four applications are executing simultaneously. Okay, now multiple tasks are doing like these threads. See how many threads here we have? Okay, 3000 around. Okay, the processor 257 processes we have. Okay, now here if you observe that each and every process having separate ID, PID in the sense like a process ID. Okay, I'm saying like only one Chrome is open, but internally the Chrome have multiple processes. See here, every process has multiple ID. How many processes here we have for the Chrome related? Okay, everything is running only. See here, everything is running. Okay, now each and every application has a separate process ID. Okay, separate process ID here we have. Okay, now like this internally, now 259 processes. Okay, within the 259 threads are working like 3000. Now these threads are doing multiple tasks. Okay, these many tasks these threads are doing. Okay, that's why each and every application internally, if you're using multi-threading concept, the response time is more or less, and it will increase the performance. Okay, now that's about like a multi-threading concept. Now, where we can use this multi-threading concept. Okay, now where we can use this multi-threading concept. Now we can develop uh, multimedia graphics. Okay, multimedia graphics, we can develop it. Now again, if you want to develop like animations also, we can develop animations. Now video games also we can use it. Okay, now if you want to develop like a web servers, okay, application servers also we can develop by using multi-threading concept. Okay, now if you want to develop like in the case of old languages, we don't have any multi-threading concept, but Java is by default a rich multi-threading API. Okay, rich multi-threading API. Now by using Java, if you create like any application internally, we have by default rich multi-threading API. Okay, it will create like a less response, sorry, like a more response applications. It's created by using Java. Okay, now here the main point is what, till now whatever the examples we executed, every example, even though like 1,000 or 20,000 lines of code, it's executed by only one thread. Simply one person, you can call it internal. Okay, one person is executed. Okay, now even though this 10,000 lines of code is executed by only one person. Okay, by using multi-threading concept, I'm going to create like one more thread. Okay, now how many threads you want, you can create a number of threads. Okay, you can create like any number of threads. That's the point. Okay, now here, if we want to use that multi-threading concept, if you want to create like one more thread, by default every time automatically one thread is executing. Okay, now observe carefully here. uh, oh, yeah, now I'm going to write something here. SY4. Now welcome to multi-threading concept. Okay, now right click, run as Java application. Now we got out. But suppose simply here I'm going to remove this semicolon. Now we are getting error. Okay, now right click, run as Java application. Now we are getting error. Okay, can you please read the error once?
Yeah, syntax error. Insert semicolon to the block statements.
Okay, now here my question is what? See here, exception in thread main. Okay, java.lang error. Now as well as com.demo.multi.demo main here we have. Okay, if you consider this main and this main, both are same or different?
Yeah, same.
Same, different, same or different? Okay, now see here, this main is a method. Okay, see here, this main is a method present in the demo class. This demo class present in the com.demo.multi package. Now this main is a thread. Okay, thread. Till now I told you like this main method is executed by the JVM. Okay, JVM. After getting the chance of JVM, who will execute this main method in the sense the main thread is executed, okay, the logic of entire class whatever we have, okay, the main method is executed by the internally the main thread only, okay, that's what's here. Exception in a thread main, okay, java.lang error as well as com.demo.multi.demo. Main, this main is a method, this main is a thread, okay. Now we have the main thread also we have, okay. Now by default we have one thread. What is the thread? Main thread we have, okay. Now by using multi-threading concept, now we need to create a one more thread, okay. If you want to create like one more thread, now we can create a multiple threads, okay. Then thing is what, how to create a thread, okay, how to create a thread, that's a point. Now we have two ways to create a thread, okay. We have two ways to create a thread. The first one, by extending a thread class, okay. Now our class is extends with, okay, thread class, okay. Thread is a predefined class, okay. Thread is a predefined class. Now again second one, our class is implements with runnable interface, okay. Now runnable is a predefined, okay, interface, okay, predefined interface. Now here we have two ways to create a thread. Now first one is by extending a thread class by implementing runnable interface, okay. Now whatever the class you created, that class should be created a extension with the thread class, okay. That class should be implemented with runnable interface, then only the thread is created, okay, other thread is created. Now if you want to create a thread, okay, now uh, here we need to use these two process like thread and runnable, okay. Now do you know Samantha, heroine? Okay, now what is the sweet name for Samantha?
Sam.
Sam we can call. Okay, now basically Sam in the sense like it's not Samantha. Now it's a single abstract method, okay, single abstract method. Now here what is this method here we have? What is a single abstract method? Now if we want to create one more thread, okay, if we want to create like one more thread, now it's a mandatory to use one method, that is abstract method. The method name is like a run method, okay. This run method is a abstract method. Now where it is a present? Now it is a present in a runnable interface, okay. It's a present in runnable interface. Now in the runnable interface we have only one abstract method, that is the run method, okay. Now this type of interface we can call, okay, this type of interface we can call a functional interface, okay. Functional interface, observe carefully here. Java P, Java data, lang data, runnable. See here, okay, in the interface of runnable, we have only one method, that is a run method. Okay, this run method is only one method we have. Okay, that is the abstract method. Okay, that is abstract method. Now, okay, this type of interface we can call the functional interface. Just to give a minute. Yeah. Now here it is a mandatory to use run method in the multi-threading concept. Okay, if you want to create one more thread, it is a mandatory to use run method. Okay, but suppose if you don't want to use run method, don't go with the multi-threading concept. That's the point here. Okay, if you want to create like if you want to use multi-threading concept, it is a mandatory to use run method. Okay, now if you don't want to use run method, don't go with the multi-threading concept. Okay, that is the main point here. Okay, this run method is present in the third class and it is also present in the runnable interface. Okay, now already in the interface we have seen run method. In the third class also we have run method. Now Java P, now Java dot lang dot thread class. Okay, now you can see here somewhere we have run methods here. Okay, now it is a mandatory to use a run method. Okay, now, because of this run method only, the child thread is creating. Main thread is already there. Okay, main thread is by default we have. But whatever we are creating, one more thread, that is the child threads. Okay, those are the child threads. Okay, simple example. Uh, I will explain here. Observe carefully here. Now, I'm going to create like my thread is a class name. Okay. Now, the first one simply the first way. Now, class is extends with thread class. Okay, now this class is extensive with thread class. Observe carefully here. Right now it is a normal class only, right? Okay, this class is what normal class only. Okay, right now. Now for suppose this class is extensive with thread class, it's a predefined class. Okay, now observe carefully here. Now our class is acting as a thread class. Why our class is acting as a thread class right now? Earlier it is a normal class only. Okay, now earlier it is normal class only. Now, whenever I extend from the thread class, then our class is acting as a thread class. Why?
Extend, we are using extends thread.
Okay. Now, because of extends, whatever the properties we have in the thread class, the entire property is going to be entered into a in the my thread. Now, the my thread is acting as a thread class. Okay. Simply, we can consider thread class. Whatever the methods here we have in this thread class, all the methods are entered into in this class. Okay, now this class is acting as a thread class. Okay, now here in the thread class we have one method, right? Now what is that? Run method. Now public void run method. Okay, now here I'm going to write some logic for int I is equal to 0, I less than or equal to 10, now I plus plus. Now SYSO, I am child thread. Okay, I am child thread. Now the same logic, the same logic. Okay, yeah, I am main thread. Okay, I am main thread. Now basically here, wherever you wrote okay, in the single program, it's executed by the main thread. Now this logic is executed by the main thread. Okay, this logic is executed by the child thread. Okay, now if I execute, what is the output right now? I am main thread only, I will get, but I want to execute like child thread also. Then how I can execute the child thread logic?
By creating an instance variable for that method.
Exactly. Now, my thread class object we need to create it. Now, my thread, okay, empty is equal to new my thread. Now, empty dot run method. Okay,
Run method.
okay. Now, if I execute right click run a Java application, now say the both the threads are executing. But in this case, these two logics are executed by the main thread only. Now, why? We are getting output, right? We got output. But how I'm saying, okay, now the two threads are executed by only main thread. If we consider here we have the main thread, here we have the child thread. Okay, I told you right, the run method in the sense like it is a child thread. It is a child thread. ఓకే. ఈ రన్ మెథడ్ అనేది చైల్డ్ థ్రెడ్ నుంచి ఎగ్జిక్యూట్ అవుతుంది. ఓకే. ఈ లాజిక్ అనేది మెయిన్ థ్రెడ్ నుంచి ఎగ్జిక్యూట్ అవుతుంది. ఓకే. దిస్ లాజిక్ ఈస్ ఎగ్జిక్యూటెడ్ బై ద మెయిన్ థ్రెడ్. బట్ నేను ఇప్పుడు చెప్పే పాయింట్ ఏంటి అంటే, ఇప్పుడు మీరు ఎగ్జిక్యూట్ చేసిన లాజిక్ అనేది ఎగ్జిక్యూటెడ్ బై ఓన్లీ వన్ థ్రెడ్, దట్ ఇస్ అ మెయిన్ థ్రెడ్ ఓన్లీ. ఓకే. ఇప్పుడు మీరు కన్సిడర్ చేసి ఇక్కడ చూడండి, ఇక్కడ మల్టీ థ్రెడింగ్ కాన్సెప్ట్ అప్లై కాలేదు. ఓకే. ఇంతవరకు మీరు
అవును.
ఎలా కాల్ చేశారో ఒక మెథడ్ ని అలానే కాల్ చేశారు. ఇది నార్మల్
హ్మ్.
మెథడ్ కాలింగ్ అంతే కదా. ఇప్పుడు
అవును.
ఇన్స్టెంట్ మెథడ్ అయితే ఆబ్జెక్ట్ క్రియేట్ చేసి ఆబ్జెక్ట్ రిఫరెన్స్ కాల్ చేశారు. ఓకే. దిస్ మెథడ్ కాలింగ్ ఈజ్ నార్మల్ మెథడ్ కాలింగ్. ఓకే. ఇంతవరకు మనం ఎలా చేసామో అలానే కాల్ చేసాం. బట్ ఇఫ్ యూ వాంట్ టు క్రియేట్ ఎ థ్రెడ్, ఇఫ్ యూ వాంట్ టు కాల్ చైల్డ్ థ్రెడ్, దట్ ఈస్ అ డిఫరెంట్ ప్రాసెస్. ఓకే. అబ్జెక్టివ్లీ హియర్ ఇక్కడ నేను ఏం చేయట్లేను, జస్ట్ లిటిల్ బిట్ చేంజెస్. The same empty dot, I'm going to use the start method. Okay, now this method will call run method
Thread.
internally.
Hmm.
Okay, okay, whenever I am using the start method, this start method internally calls the run method, then the child method is created. Okay, it's executed by the, ఓకే, దిస్ లాజిక్. నౌ సియర్ అబ్జెక్టివ్లీ ఇప్పుడు బేసిక్ గా ఇలా కాల్ చేస్తే మనకి నార్మల్ గా అయితే ఇలా ఎగ్జిక్యూట్ అవ్వదు, ఎందుకంటే రన్ మెథడ్ వేరు, స్టార్ట్ మెథడ్ వేరు. కానీ మల్టీ థ్రెడింగ్ కాన్సెప్ట్ ఏంటి అంటే, నువ్వు థ్రెడ్ స్టార్ట్ అవ్వగానే ఇంటర్నల్ గా ఈ రన్ మెథడ్ ని కాల్ చేస్తుంది. ఓకే, ఇంటర్నల్ గా ఈ రన్ మెథడ్ ని కాల్ చేస్తుంది, అప్పుడు మాత్రమే ఈ లాజిక్ ఓపెన్ అవుతుంది. నౌ at this time the child thread is going to be creating. Right click on a Java application. Now again the both childs are executing. Okay, both childs are executing. Now observe carefully here. But suppose now 2 plus 3, what is output? 5.
5.
Okay, now if I execute tomorrow, what is the output of 2 plus 3?
5.
After 2 days,
5.
after 10 days,
Yeah, 5. 2
same
plus.
output. But in the case of observe carefully here, observe that output right now. I executed like this. Now see the logic is changed. Again the logic is changed. Okay, again the logic is changing. Now for every execution the logic is changing. Okay, the output is changing. Okay, means the output we cannot predict in the multi-threading application. Okay, now in this case only, okay, in this case we cannot predict the output, which thread is going to be executing first. Here we have the two threads, one child thread, one main thread. Okay, one child thread and one main thread. Now simply we cannot predict that which thread is executing first. Okay, now then how I can predict that? Then who will predict that? One person is there that is decided which thread is going to be executing. That person is a thread scheduler. Okay, this thread scheduler will decide which thread is going to be executing first. Okay, now this thread scheduler is responsible to, okay, give the chance to which thread is going to be executing first, child thread or main thread. But here sometimes child thread is going to be executing first, sometimes main thread is going to be executing first. Okay, simply now in this case we cannot predict that out, but now it's decided by the thread scheduler only. Observe carefully here. Now whenever I call the start method, the start method is going to informing to thread scheduler, okay, I am going to start. Okay, I am going to start. Now the thread scheduler is saying stop, okay, wait 1 minute time. Okay, now you can perform some mandatory operations. Okay, now which thread you want to execute? Okay, what is your thread, what is your logic? Okay, it is asking by the thread scheduler. Okay, the start method, okay, it's performing some mandatory operations, again then it will call finally the run method. Okay, run method. But suppose uh, your friend is staying like some kind of apartment, like is living 100th floor. Okay, now you're going to enter into that apartment, but security is going to be stopped. Why? In the sense, now you need to write some your phone number, your bike number, all these things. means the security in the thread scheduler. Okay, you are the start method. You need to perform some operations. What kind of operations? You need to fill the form. Okay, you need to give address, your phone number, all these things. Okay, then only you can enter into that apartment. Okay, now the thread scheduler, the start method, before going to execute the child thread, the start method is informing to the thread scheduler. It is performing some mandatory operations. Then only the start method internally calls the run method. Then the logic is executed by the child thread only. Okay, now I will show you that this logic is executable child thread. This logic is executed by the main thread. I will show you that. Okay, now this is the one way to create a thread. Okay, observe carefully here. Now, here I'm going to create like one more method, public void run method into age. Now, sy4. Now, my age is simply here age. Observe carefully here. Right now, I'm using the same case. Okay, code is the same, nothing to change. If I call the 22 line, which run method is going to be called? That's the point. Anybody guess? Here we have basically what I tell you now. Simply the start method is called run method internally. Okay, basic start method అనేది run method ని కాల్ చేస్తాను. కానీ నేను ఇక్కడ రెండు రన్ మెథడ్ రాసానే, ఇది రన్ మెథడ్, ఈ రన్ మెథడ్. మరి ఏ రన్ మెథడ్ ని కాల్ చేస్తాను? దట్ ఈస్ ద పాయింట్.
Hmm.
ఫస్ట్ వన్, సెకండ్ వన్.
First one,
ఫస్ట్ వన్. వై నాట్ సెకండ్ వన్?
because we are not initiating any parameter anywhere.
Exactly. That is the one point. Okay, that is the one point. And one more point is what the start method is always calling default run method only. Okay, by default run method, whatever we mention in the start method, only this run method is going to be calling. Okay, that is a point here. Okay, now if you have the two run methods in that given program, only the start method is calling by default run method only. It's not going to call other run methods here. Right click, run as Java application. Sure, the child is going to be executed. For suppose my logic is different right now. Now public, now void start. Now sy4. I am start method. Now here the start method basically calls run method internal. Now in this case I'm using by default run method, I'm using start method, I'm using like a start method, run method again with a parent. Which method is going to be called? Just guess it.
Maybe 19 start method and run method.
Okay, you're saying like 19 and both,
6. Yeah.
both are two, both are only one,
Both.
both. Okay, right click, run as Java application. Now observe carefully here, we called only one method, that is the start. Okay, now if we have the start method in the logic, inside the logic, now it will call only the directly start method only. It will not call the run method. Okay, simply we cannot use any the start method in our program now whenever we are creating our child thread. Okay, that is the point. Now are you clear the points now why we are not using that run method and why we are not using again start method in the child thread cases? Okay, if you're using again and again multiple methods name same, simply it's execute, it's not going to be executing, it's execute only the default run method only. Okay, now this is the first case. Our class is extensive with a third class. Okay, this is the first case. Now next one is what? By implementing runnable interface only. Okay, now our class is implementing with a runnable interface. Okay, our class is implemented with a runnable interface. Now okay, logic is same but little bit changes here. We have observed carefully here. Again I'm going to create like a my runnable. Okay, now it is the second case. Now class is implements with a runnable interface. ఓకే. ఈ ఇంటర్ఫేస్ కి వన్ మోర్ నేమ్ ఏంటి అంటే ఫంక్షన్ ఇంటర్ఫేస్ కూడా అంటాం. ఎందుకు అంటే ఫంక్షన్ ఇంటర్ఫేస్ లో ఓన్లీ వన్ అబ్స్ట్రాక్ట్ మెథడ్ మాత్రమే ఉంటుంది. బట్ నార్మల్ ఇంటర్ఫేస్ లో మనం ఎన్ని అబ్స్ట్రాక్ట్ మెథడ్స్ అయినా రాసుకోవచ్చు. బట్ ఫంక్షన్ ఇంటర్ఫేస్ అని చెప్తే ఓన్లీ వన్ అబ్స్ట్రాక్ట్ మెథడ్ ఉంటుంది. దట్స్ వై సింగిల్ అబ్స్ట్రాక్ట్ మెథడ్. ఇట్స్ కాల్డ్ సామ్. ఓకే. నౌ our class should be implements with implements with a runnable interface. Okay, runnable interface. Now runnable. Okay, now why our class is getting error? Any idea? This concept we learn in the hooks. Why our class is getting error?
We need to create an abstract class method, override method.
Exactly. Now in the runnable we have abstract method. Okay, these methods are not allowed in the normal classes. ఓకే, ఈ మై రనబుల్ అనేది క్లాస్ కదా, ఈ క్లాస్ లోకి ఈ అబ్స్ట్రాక్ట్ మెథడ్ అనేది నాట్ అలౌడ్. బేసిక్ గా అబ్స్ట్రాక్ట్ మెథడ్స్ మనం నార్మల్ క్లాస్ లో యూజ్ చేయలేము కదా. అందుకనే నా వీ నీడ్ టు ప్రొవైడ్ ఇంప్లిమెంటేషన్ ఫర్ ద లాజిక్ ఆఫ్ అబ్స్ట్రాక్ట్ మెథడ్ వాట్ ఎవర్ వీ హ్యావ్ ఇన్ ద రనబుల్ ఇంటర్ఫేస్. ప్లేస్ ద కర్సర్, యాడ్ అండ్ ఇంప్లిమెంటెడ్ మెథడ్స్ హియర్. ద ఓవర్ రైడెడ్ run method we have in the runnable interface. Now we need to provide implementation. Objectively the same logic I am providing without changes anything. Now for int I is equal to 0. Now I less than or equal to 10, I plus plus. Now sy so now I am see the thread. Okay, the same logic I am going to write executed by Rama thread. Okay, now tell me how I can call how I can execute. Tell me.
By creating an object for my runnable class.
Okay, my runnable yamr is equal to new my runnable. Okay, yeah, next one.
Yeah, for that mr dot start.
Yamr dot okay, there is no start method here. Whatever you said here, mr dot start, there is no start method, we are getting error.
Okay.
If you place the cursor, the method start is undefined for the type of my runnable. ఓకే, ఇక్కడ చూడండి ఎందుకు రాలేదు మనకి స్టార్ట్ మెథడ్ అనేది. చూడండి ఇక్కడ మీరు అబ్జర్వ్ చేస్తే ఈ రనబుల్ ఇంటర్ఫేస్ ని మనం ఇంప్లిమెంట్ చేస్తున్నాం. ఇంప్లిమెంట్ చేస్తే ఈ రనబుల్ ఇంటర్ఫేస్ లో ఏదైతే మెథడ్స్ ఉన్నాయో అన్ని మెథడ్స్ మనకు వచ్చేస్తాయి. ఇక్కడ ఎన్ని మెథడ్స్ ఉన్నాయి? రన్ మెథడ్ ఒకటే ఉంది. అలాంటప్పుడు ఎన్ని మెథడ్స్ వస్తాయి ఈ క్లాస్ లోకి? ఓన్లీ వన్ మెథడ్ మాత్రం వచ్చింది. కానీ ఈ రన్ మెథడ్ ని కాల్ చేయాలంటే మనకి ఏం కావాలి? స్టార్ట్ మెథడ్ కావాలి. బేసిక్లీ స్టార్ట్ మెథడ్ అనేది ఎక్కడ ఉంటుంది? ఓన్ థ్రెడ్ క్లాస్ లో మాత్రమే ఉంటుంది. చూడండి ఈ థ్రెడ్ క్లాస్ లో నౌ స్టార్ట్ మెథడ్ ఇక్కడ చూడండి, స్టార్ట్ మెథడ్ ఉంది, ఇక్కడ ఉంది స్టార్ట్ మెథడ్. అంటే అందుకనే ఇక్కడ మనం ఈ కాన్సెప్ట్ యూజ్ చేసినప్పుడు ఇమీడియట్ గా వచ్చేసింది. ఎందుకంటే ఈ క్లాస్ కూడా థ్రెడ్ క్లాస్ కాబట్టి ఆటోమేటిక్ గా వాట్ ఎవర్ ద మెథడ్స్ వీ హ్యావ్ ఇన్ ద థ్రెడ్ క్లాస్, ద సేమ్ మెథడ్స్ ఆర్ ఎంటర్ ఇన్ టు అవర్ క్లాస్. దట్లీ వీఆర్ గోయింగ్ టు గెట్ empty dot start. I created object, I got method. ఓకే, కానీ సేమ్ క్లాస్ నేను ఆబ్జెక్ట్ క్రియేట్ చేసిన రాలేదు. ఎందుకంటే ఈ క్లాస్ లోకి ఏ మెథడ్స్ రాలేదు, ఒకటే మెథడ్ వచ్చింది, దట్ ఈస్ రన్ మెథడ్. వీ ప్రొవైడెడ్ ఇంప్లిమెంటేషన్. ఓకే, కానీ ఈ రన్ మెథడ్ ని కాల్ చేయాలంటే మనకు స్టార్ట్ మెథడ్ కావాలి. ఓకే, మరి స్టార్ట్ మెథడ్ ఎక్కడ ఉంది? బేసిక్ థ్రెడ్ క్లాస్ లో ఉంది. నౌ వాట్ వీఆర్ గోయింగ్ టు డూ హియర్, we need to create thread class object. Okay, now if you want to call run method, now we required start method. Okay, start method, but the start method is present in where? In thread class. Okay,
method.
If you want to create the start method, we need to create an object of thread class. Now thread predefined class t is equal to new thread. Okay, thread అనే predefined class కాబట్టి మనం ఆబ్జెక్ట్ క్రియేట్ చేయొచ్చు. ఓకే, Now, object creation of thread class. Okay. Now, object create based on the object reference, we can call start method. T dot start method. See here, we got it. And the T dot start method we got. Okay. Now, if I execute output, right click, run as Java application. But I am Rama thread only executed. By why? Why it's not executed? See the thread. Start method call చేశాను కదా, మళ్ళీ ఎందుకు ఎగ్జిక్యూట్ అవ్వలేదు? ఎనీ ఐడియా?
నో అన్న.
ఓకే, యా, ఇక్కడ చూడండి. బేసిక్ గా ఈ స్టార్ట్ మెథడ్ అనేది ఇంటర్నల్ గా ఏం కాల్ చేస్తుంది? రన్ మెథడ్. ఓకే, థ్రెడ్ క్లాస్ లో ఉన్న రన్ మెథడ్ కాల్ చేస్తుంది. ఈ థ్రెడ్ క్లాస్ అనేది ఎక్స్ప్లిసిట్ గా నేను క్రియేట్ చేశాను కదా. ఇక్కడ చూడండి, ఫస్ట్ ఎగ్జాంపుల్లో థ్రెడ్ క్లాస్ లో ఉన్న మెథడ్స్ అన్ని ఇందులోకి వచ్చేసాయి. అంటే ఈ మై థ్రెడ్ క్లాస్ లోనే రన్ మెథడ్ ఉంది, ఉందా లేదా? ఈ మై థ్రెడ్ క్లాస్ లో ఈ రన్ మెథడ్ ఉంది. ఓకే, అందుకని ఏం చేశాను, నేను మై థ్రెడ్ క్లాస్ ఆబ్జెక్ట్ క్రియేట్ చేసి ఎంటీ డాట్ స్టార్ట్ మెథడ్ కాల్ చేశాను. ఓకే, ఇక్కడ మరి ఈ రన్ మెథడ్ ఎక్కడ ఉన్నది? మై రనబుల్ లో ఉంది. నేను ఆబ్జెక్ట్ అయితే క్రియేట్ చేశా, కానీ స్టార్ట్ మెథడ్ దేని, ఏ ఆబ్జెక్ట్ రిఫరెన్స్ కాల్ చేశాను? థ్రెడ్ క్లాస్ ఆబ్జెక్ట్ కాల్ చేశాను. నేను ఎంఆర్ డాట్ స్టార్ట్ మెథడ్ కాల్ చేస్తేనే ఆ స్టార్ట్ మెథడ్ అనేది ఇంటర్నల్ గా రన్ మెథడ్ కాల్ అవుతుంది. కానీ ఇక్కడ ఏంటి, ఈ ఆబ్జెక్ట్ డిఫరెంట్, ఈ ఆబ్జెక్ట్ డిఫరెంట్. ఓకే, నౌ టీ డాట్ స్టార్ట్ అనేది ఈ థ్రెడ్ క్లాస్ లో ఉన్న రన్ మెథడ్ నే కాల్ చేస్తుంది, కానీ మనకి ఎక్కడ కాల్ అవ్వాలి? ఈ మై రనబుల్ క్లాస్ లో ఉన్న రన్ మెథడ్ ని కాల్ చేయాలి. ఓకే, అర్థమైందా పాయింట్?
యా, అర్థమైందన్న.
ఓకే, నౌ then how we need to call like this? Simply here, this object అంటే ఈ మై రనబుల్ ఆబ్జెక్ట్ ఏదైతే ఉందో ఈ ఆబ్జెక్ట్ నేను ఈ థ్రెడ్ కన్స్ట్రక్టర్ లో పాస్ చేస్తే ఆటోమేటిక్ గా ఈ మెథడ్ అంటే ఈ ఆబ్జెక్ట్ రిఫరెన్స్ లో ఉన్న రన్ మెథడ్ ఆటోమేటిక్ ఈ థ్రెడ్ క్లాస్ లోకి ఎంటర్ అయిపోతుంది. ఓకే, ఈ థ్రెడ్ క్లాస్ లోకి ఎంటర్ అయిపోతుంది. అప్పుడు ఈ స్టార్ట్ మెథడ్ ఇట్స్ గోయింగ్ టు బి కాలింగ్ బై దిస్ రన్ మెథడ్ ఇంటర్నల్. దట్స్ అ పాయింట్. నౌ దిస్ ఇస్ ద ఓన్లీ డిఫరెన్స్ బిట్వీన్ రనబుల్. నౌ control is right click, run as Java application. Now see here, the both the threads are going to be called. Okay, now this is a way. Now we have two ways to create a thread. One is implementing runnable interface by extending a thread class. Then which one is the best? Okay, okay, దగ్గర two ఉన్నాయంటే which one is the best? First we need to write. Okay, even though in the interview room, whenever we have the two things, simply the question is raising what is the differences between them. Okay, if you have that more than one, simply he will focus on like simply the differences only. Okay, why we need two, why not one? Okay, one enduku ledu, two enduku unnai ikkada. Okay, now based on the requirement we can use it. Basically చెప్పాలంటే రెండు బెటర్ ఇక్కడ. ఎందుకు రెండు బెటర్ అంటే, ఇఫ్ యూ వాంట్ టు పర్ఫార్మ్ లైక్ మల్టిపుల్ ఆపరేషన్స్, ఓకే, మల్టిపుల్ ఆపరేషన్స్ పర్ఫార్మ్ చేయడానికి మనకు మల్టిపుల్ మెథడ్స్ ఉండాలి. ఆ మల్టిపుల్ మెథడ్స్ ఉన్నవనేది ఈ థ్రెడ్ క్లాస్ లో మాత్రమే మల్టిపుల్ మెథడ్స్ ఉన్నాయి. మరి రనబుల్ ఇంటర్ఫేస్ ఎందుకు యూజ్ చేయాలి? ఓకే, ఈ రనబుల్ ఇంటర్ఫేస్ ఎందుకు యూజ్ చేస్తామంటే, ఫర్ సపోజ్ ఈ థ్రెడ్ క్లాస్ యూజ్ చేసి నేను మల్టిపుల్ ఇన్హెరిటెన్స్ పాస్ చేయలేను. ఎందుకు? మల్టిపుల్ ఇన్హెరిటెన్స్ అంటే ఏంటి? ద క్లాస్ ఈస్ ఎక్స్టెన్స్ విత్ మల్టిపుల్ క్లాసెస్. ఓకే, దట్ ఈస్ వన్ predefined class. But suppose object is one predefined class. ఓకే, ఇక్కడ మనకి ఎర్రర్ వస్తుంది. ఎందుకు? మల్టిపుల్ ఇన్హెరిటెన్స్ అనేది పాసిబుల్ అవ్వట్లేదు ఇక్కడ. ఓకే, థ్రెడ్ క్లాస్ యూజ్ చేసి నాకు రిక్వైర్మెంట్ ఏంటి అంటే మల్టిపుల్ ఇన్హెరిటెన్స్ రిక్వైర్మెంట్ ఉంది. ఓకే, థ్రెడ్ క్లాస్ యూజ్ చేసి మల్టిపుల్ ఇన్హెరిటెన్స్ కాన్సెప్ట్ నేను చేయలేను. అదే కాన్సెప్ట్ నేను ఇది రన్నబుల్ ఇంటర్ఫేస్ లో ఇంకో ఇంటర్ఫేస్ ఇంప్లిమెంట్ చేస్తా. ఫర్ సపోజ్ యాక్షన్ లిజనర్ వి హ్యావ్. ఓకే, ఇది యాక్షన్ ఆల్సో ఇంటర్ఫేస్. ఇక్కడ చూడండి మనకి ఎర్రర్ రావట్లేదు. ఇక్కడ చూడండి ఏం ఎర్రర్ రావట్లేదు. ఓకే, ఇక్కడ అన్ఇంప్లిమెంటెడ్ మెథడ్ ఉంది, దాన్ని ప్రొవైడ్ చేసుకోవాలి. అంటే ఏంటి? ఈ రన్నబుల్ ఇంటర్ఫేస్ యూజ్ చేసుకొని మనం మల్టిపుల్ ఇన్హెరిటెన్స్ కాన్సెప్ట్ చేయొచ్చు. కానీ థ్రెడ్ క్లాస్ యూజ్ చేసుకొని మన మల్టిపుల్ ఇన్హెరిటెన్స్ ఇస్ నాట్ పాసిబుల్ బై యూజింగ్ థ్రెడ్ క్లాస్. దట్ ఈస్ ద మెయిన్ డిఫరెన్స్. Now, if you want to go with like multiple requirements, go with the thread class, not for the runnable interface. Okay, that's a point. అర్థమైందా ద డిఫరెన్స్? ఎందుకు మళ్ళీ చెప్పనా? ఓకే, ఇక్కడ మల్టిపుల్ ఇన్హెరిటెన్స్ కాన్సెప్ట్ గుర్తుందా? మల్టిపుల్ ఇన్హెరిటెన్స్ ఏంటి వన్ చైల్డ్ టూ పేరెంట్స్. ఓకే,
Hmm.
ఇది మైథడ్ అనేది చైల్డ్, ఇది పేరెంట్, ఇంకో పేరెంట్ కూడా కావాలి. ఓకే, ఇంకో పేరెంట్ ఆబ్జెక్ట్ అనేది సూపర్ క్లాస్. నేను ఆబ్జెక్ట్ తీసుకుంటాను, ఆబ్జెక్ట్ క్లాసే, అది కూడా ఒక క్లాసే. ఓకే, ఇదొక క్లాసు, ఇదొక క్లాస్. మనకు ఎర్ర వస్తుంది చూడండి, మొత్తం ఎర్ర వచ్చేసింది. అంటే ఏంటి? నౌ multiple instance is not possible in Java level. It's a possible in interface level. That's why
Interface.
Rumble is interface. I can take like one more interface. Okay, it will work. Okay. Okay, you can take any interface. Okay, it will work. Okay, that's a difference. Okay, మీకు మల్టిపుల్ ఇన్హెరిటెన్స్ కాన్సెప్ట్ కావాలి అంటే యూ కెన్ చూస్ రనబుల్ ఇంటర్ఫేస్. ఓకే, మీకు మల్టిపుల్ ఇన్హెరిటెన్స్ అవసరం లేదు, ఓన్లీ మెథడ్స్ కావాలి ఇంటర్నల్ గా థర్డ్ క్లాస్ అంటే యూ కెన్ గో విత్ థర్డ్ క్లాస్. బట్ మోస్ట్లీ వీఆర్ యూజింగ్ థర్డ్ క్లాస్, రేర్ కాంబినేషన్ వీఆర్ యూజింగ్ రనబుల్ ఇంటర్ఫేస్. దట్స్ పాయింట్. ఓకే, నా దీస్ ఆర్ టూ వేస్ టు క్రియేట్ థర్డ్. బట్ మనకి ఇంకా ఒక పాయింట్ క్లియర్ అవ్వలేదు. ఓకే, ఇక్కడ ఎన్నిసార్లు ఎగ్జిక్యూట్ చేసిన అవుట్పుట్ అనేది సేమ్ రావట్లేదు. Okay, for every execution we are getting different output. Okay, now I told you already, like it's executed by the thread scheduler. Why it's executing like that? What is the purpose? Okay, now అదొక పాయింట్. అండ్ అగైన్ నేను ఇంతవరకు చెప్పాను, ఈ లాజిక్ ఎగ్జిక్యూట్ చేసేది మెయిన్ థ్రెడ్, ఈ లాజిక్ ఎగ్జిక్యూట్ అయితే చైల్డ్ థ్రెడ్ అని చెప్పాను. నేను చెప్పడం
Hmm.
మాత్రం నేను చూడలేదు. ఓకే, దోస్ థింగ్స్ విల్ సీ టుమారో. ఓకే, ఐ హోప్ లైక్ టిల్ నౌ ఆర్ యూ క్లియర్? ఎనీ డౌట్స్? ఓకే, ఇంతవరకు క్లియర్ ఉంటేనే రేపు చెప్పేది అర్థమవుతుంది కొంచెం నీట్గా.
యా, దాదాపు క్లియర్ ఉందన్న. మళ్ళీ ఒకసారి వీడియో చూస్తాను నేను.
ఓకే ఓకే, కార్తిక్ అండ్ మహేష్.
ఓకే, బాగుంది. అంతే, ఇంకోసారి చూస్తా వీడియో చూస్తా. ఐ మీన్ ఇంకోసారి సెషన్ చూస్తే అర్థమవుతుంది.
ఓకే ఓకే, నౌ ఎనీ డౌట్ జస్ట్ రీచ్ మీ ఎనీ టైం. ఓకే, yeah, we'll meet tomorrow. We have some more points, some more concepts in the multi-threading. Okay, we'll discuss it. Okay then.
ఓకే బాబు, బాయ్.
See ya.
Bye, Anna.
Bye bye.
బాయ్ బాయ్.